Greetings. I'm K. Jayavardhan Reddy. I'm now here to share my understanding about converting a square wave into a triangular wave using an operational amplifier. For this, we require two operational amplifiers, out of which the first operational amplifier acts as an comparator and the second operational amplifier acts as an integrator. The operational amplifier which acts as a comparator converts the input signal into a square wave. This square wave, which is fed to the integrator, converts it into a triangular wave, and which is seen finally seen through this oscilloscope. Let us first see how this comparator converts the input voltage into a square wave. It is assumed that the capacitor that is connected to the inverting terminal of the comparator, the voltage across this capacitor is assumed to be 0. It is 0. And the output of the comparator is assumed to be offset voltage, positive offset voltage, which is fed back to the non-inverting terminal of the comparator. Now, the voltage in the non-inverting terminal is given by the expression V1 is equals to plus Vsat into R1 by R1 plus R2. Now, the capacitor starts charging towards the plus Vsat. The voltage across this capacitor keeps increasing. At a particular instant of time, the voltage across this capacitor, which is same as the voltage of the inverting terminal of the comparator, increases than the voltage in the non-inverting terminal. As we know from the understanding of what a comparator is, we know that when the voltage across the inverting terminal is greater than the voltage across the non-inverting terminal, we get a negative saturation voltage. So in this case, we get a negative saturation voltage at the output of the comparator. Now, this negative saturation voltage is again fed back to the terminal of the non-inverting terminal of the comparator. Now, the voltage at the non-inverting terminal changes to minus Vsat into R1 by R1 plus R2. Now, the capacitor decreases its voltage and it goes below the voltage across the non-inverting terminal. So, the non-inverting terminal voltage will be greater than the inverting terminal voltage. So, the output of the comparator will be plus Vsat. So, in this way, the output of the comparator keeps changing from plus Vsat to minus Vsat and minus Vsat to plus Vsat and so on. The waveform of the changing of the output of the comparator is given by this. This is plus Vsat, it goes again minus Vsat, again goes plus Vsat, it goes to minus Vsat and so on. Now let us see how this square wave is converted into a triangular wave with the help of an integrator operational amplifier. Let us first see what is an integrator. The integrator is a circuit which has a capacitor as the feedback. This output voltage of the integrator is given by this expression Vout is equals to minus integration of V in by RC plus integration constant. So it basically integrates the input voltage current. So what is an input voltage current? Voltage. It is a square wave. The square wave gets integrated into triangular wave. This is a positive saturation voltage, which is integrated into a negative ramp, and this is negative saturation voltage, which is integrated into a positive ramp, and so on. In this way, we get a triangular wave using an integrator. Let us now see how to design the same circuit using less components. This is a circuit that is designed for observing a triangular wave using less components. In this, we gave a feedback from an output of the integrator to the output of the comparator. In this, we can decrease the number of components that is used for getting a desired output. Let us now simulate the schematic and observe the result. I have designed the circuit like this and gave the output of the comparator to the channel A and output of the integrator to channel B. From our understanding in the previous minutes, we have seen that we have to get a square wave from the comparator and a triangular wave from the integrator. Let us see if we get a square wave from channel A and a triangular wave from channel B or not. Let us now simulate this and observe. So we get a square wave from the channel A and triangular wave from the channel B in this way. So hence we have proved the theory practically by using a multisim software. Thank you.